Okay. Good evening to one and all. Today we are going to discuss about the topic name is General Organic Chemistry Introduction Part. General Organic Chemistry Introduction. It is introduction part here. Okay, what is the definition of organic chemistry? Okay, here the term organic means life or signifies life. The term organic means life. Therefore, if you take all the substances, actually in chemistry there are two substances are there: organic chemistry and also organic compounds and inorganic compounds. Here, all the substances which are obtained either directly or indirectly. All the substances either directly or indirectly from living organisms like plants and animals is called organic compounds. Okay, the branch of chemistry which deals with this type of organic compounds, then the branch of chemistry is called organic chemistry. Once again repeat. Okay, all the compounds which are either directly or indirectly is obtained from living organisms like especially plants and animals. Next, we eat the food and we wear clothes, plastics, polymers, and also medicines, paper, pesticides, fuels, dyes, drugs. These are all containing organic compound. However, all compounds of carbon are not considered as an organic compounds because the compounds of carbon and other than carbon monoxide, if you take carbon monoxide, carbon dioxide, carbonates, bicarbonates containing carbon, but those type of compounds are not a organic compounds. Now, what is the history of organic compounds? History of organic compound is history. The history of organic compounds more than 2000 years ago, many philosophers recognized more than 2000 years. Many philosophers recognized the compounds, organic compounds distinct from inorganic compounds. That means which are classified into two classes. That is, the first one is vegetable origin or vegetable source, and second one is animal source, animal origin. Origin is nothing but source. The vegetable origin such as what are the vegetable origins are like sugars, sugar cane, fruits, molasses, and also fermentation liquors, fruit juices, fermentation liquors, molasses, okay, which are obtained from plants. And what is the animal origins are here? Animal origin is nothing but if you take milk, honey, and also fat. Okay, these are animal origin. Okay, what is the history of organic compounds? Simply, more than 2000 years ago, many philosophers recognized the organic compounds obtained from inorganic compound, which is distinct as a two classes or two categories. That is plant origin, vegetable origin, and as well as a animal origin. Okay, any vegetable origins such as sugars, molasses, and as well as fermentation liquors, fruit juices, animal origins like milk, honey, and fat. I hope it is clear. Okay, these are the history and vital force theory. And another topic here, vital force theory. What is vital force theory, sir? Actually, this vital force theory was proposed by Berzelius. The complex nature of organic compound and observations mentioned above led to the common belief that organic compounds were produced under the influence of some natural forces is called vital forces. Once again repeat. The complex nature of organic compound. There are millions of organic compounds. The complex nature of organic compounds and observations mentioned above led to the common belief that organic compounds were produced under the influence of some natural mysterious force exists in the molecules. This led to the vital force theory for the formation of organic compound in plants and animals. First time who proposed this vital force theory, Berzelius was one of the strong supporter of this theory. Okay, vital force theory, okay, one of the supporter of scientist that was the scientist Berzelius was one of the strong supporter to the vital force theory. I hope it is clear. And next one is how to prepare organic compound in the laboratory. The first one is preparation of urea. The preparation of urea in 1828. In 1828, first time urea chemical formula NH2, CONH2. It is a white color substance. It is used for growing of plants. Okay, he is a German scientist Friedrich Wöhler, 18th century to 1882. It is obtained urea by heating of inorganic compound ammonium cyanate or a mixture of ammonium sulfate and as well as the potassium cyanate to produce urea. Okay, once again repeat here how to prepare urea on strong heating of ammonium sulfate, preparation of urea on strong heating of ammonium sulfate. How it is ammonium sulfate is obtained? The mixture of ammonium chloride and potassium cyanate to produce ammonium cyanate and potassium chloride. On further heating of ammonium cyanate, further rearrangement to form NH2 CONH2. This name of the compound is called urea. The first organic compound prepared in the laboratory. Here, sorry, ammonium sulfate starting. Is react with potassium sulfate to form potassium sulfate to ammonium cyanate. I hope it is clear. Okay, this is information about preparation of urea. How to prepare urea. The urea is obtained from by heating of inorganic compound ammonium cyanate or mixture of ammonium sulfate and potassium cyanate. This is called ammonia. This is called ammonium sulfate. This is called potassium cyanate to produce ammonium cyanate. On further heating ammonium cyanate to produce a urea. And also some organic compound prepared other organic compounds. Preparation of other organic compounds. This reaction give a big blow to the vital force theory. In 1845, Kolbe prepared acetic acid from elements. Kolbe prepared acetic acid from the elements. And also in 1856, in 1856, Berthollet synthesized methane gas. Berthollet synthesized methane gas. In 45, Kolbe prepared acetic acid from the elements. In 1856, Berthollet prepared methane gas. And the most abundant organic compound cellulose, which is a polymer of glucose. Kekulé and Cooper. Kekulé and Cooper prepared tetravalency of carbon and wrote the first structural formula in 1874. In 1874, Van 't Hoff and Lebel suggested a tetrahedral of carbon. Okay. Van 't Hoff and Lebel. In 1874, Van 't Hoff and Lebel prepare tetrahedral model of carbon atom. Okay, this is information about modern. This is called introduction part of the general organic chemistry, and also we will discuss modern definition of organic chemistry. Okay, what is the modern definition, sir? The modern definition is nothing but organic chemistry is a branch of chemistry which deals with the carbon compound. It is also called hydrocarbons. The millions of organic compounds are there. The synthesis of urea from ammonium thiocyanate or many organic compounds were prepared and analyzed. Present about 500 millions of compounds, organic compounds. It was recognized that the chemical force in organic compounds are similar to those which exist in the organic compound. Okay, the modern organic chemistry definition is: it is a branch of chemistry which deals with the study of carbon compounds, especially hydrocarbons. Hydrocarbon is nothing but the compound containing only carbon, hydrogen and its derivatives. Okay, the organic chemistry is a branch of chemistry which deals with the carbonates compounds, especially hydrocarbons and their derivatives. Okay, carbon atom due to tetravalency can be bonded to 2, 3 or 4 carbon atoms by forming a single bond or multiple bond, either maybe linear or branched or closed chains. Okay, this is information about introduction part. And next video we will continue another video. Thank you. Okay, this is introduction part, how to prepare organic compounds in the laboratory, especially the first organic compound is prepared in the laboratory, urea. I hope it is clear. We will continue here one more video. Okay, why carbon can form maximum number of bonds, number of compounds due to? Why the carbon atoms can form maximum number of compounds? Because there are two versatile nature is there. Versatile nature of carbon atom. The first versatile nature is tetravalency. Second one is catenation property. Third one is it can form multiple bonds. What is tetravalency, sir? What is the why carbon atom can form maximum number of bonds? You can observe here. Carbon atomic number is 6. Atomic number 6 means electronic configuration 2, 4. In this outermost shell there are 4 electrons are there. In this carbon atom, to get the stability, to reach the octet configuration or duplet configuration, either losing or gaining of electron, if you take carbon try to lose 4 electrons to form carb C plus 4. Okay, 1 electron removed from the carbon, that is called ionization energy. The amount of energy is required to remove an electron from neutral atom is called ionization energy. It is also called ionization enthalpy. Okay, 2, 3, 4 electrons removed from the ion. It is very difficult. Okay, huge amount of energy is required. That's why carbon cannot exist in this form. And second one is try to gain electrons. Carbon try to gain electron to form carbide form. Here number of protons 6, electrons also 6, but here number of protons 6, number of electrons 10. Okay, 10 electrons, so 6 protons cannot hold 10 electrons. That's why carbon also cannot exist in this minus form. How to stabilize the carbon atom? In this carbon atom, we can share electron to the other atoms to get the stability. That's why carbon can share electrons to the other atoms. Okay, 1 is 2, 2 is 2, 2p2 is the electron configuration. Okay, 1 is 2, 2s1, 2px1, 2py1, 2pz1. Okay, this is called ground state electronic configuration. In ground state, carbon never form in the bond only, and the energy difference between 2s orbital and 2p orbital is very small. That's why an electron is promoted from one orbital to another orbital. It is called promotion of electron. Then the electron configuration is called excited state electronic configuration. The ground state electronic configuration of carbon is 1s2, 2s2, 2p2. Whereas the excited state electronic configuration of carbon is 1s2, 2s1, 2px1 and 2pz1. In this form, carbon can form bond. That is how many bonds? 4 bonds. That is called tetravalency. Carbon can form maximum number of bonds 4. Valency means the combining capacity of an element is called valency. And next one is catenation property. The property of an element. What is the catenation property, sir? It is a unique property of a carbon atom to link with each other. Carbon atoms to form a long straight chain or branched chain or closed chain. It is a unique property of carbon atoms are linked with either same kind of atoms, either straight chain, or if you take either branched chain, or if you take a ring chain. The unique property of a carbon atoms are linked with each other to form a long straight chain or branched chain of any length or closed rings of any complexity is called catenation property. Among various elements, this property is not available. Only carbon is a special. Carbon can exist. Tetravalency, it can form catenation property. And between carbon and carbon, either double bond or triple bond also possible. That is called multiple bonds. I hope it is clear. This is called versatile nature of carbon atom. The ability to form a double bond or triple bond. A tetravalency of carbon atom and also catenation and multiple bonds form. These the three are the versatile nature of carbon atom. I hope it is clear. Thank you. We will continue. What is hybridization, sir? Okay, hybridization was proposed by Pauling and Slater, introduced to explain the shape of the molecule. Pauling and Slater. These two are explaining to determine the shape of the molecules based on the valency bond theory. Okay, intermixing or redistribution of energy among two or more half-filled or fully filled or incomplete or empty orbitals of comparable energy to form a same number of hybrid orbital is called hybridization. Okay, based on the involving of s and p orbital, they are classified into various types. Okay, I will say once more again small definition for you. Okay, two or more different atomic orbitals of same element. Two or more different atomic orbitals of same element can intermix or redistribute their energies to form a new identical orbitals is called hybridization. Once again repeat. Carbon atomic number 6, electronic configuration 1s2, 2s2, 2p2. This is ground state electronic configuration. The excited state electronic configuration of carbon is 1s2, 2s1, 2px1, 2py1, 2pz1. Here different atomic orbitals of same element can intermix or combine and redistribute their energies. For example, one 2s orbital, one 2px orbital combine to form 2sp identical orbital. One 2s orbital and 2px 2p orbitals are combined to form 3sp2 hybrid orbitals. One 2s orbital and 2px 2py 2pz orbitals are combined to form 4sp3 hybridized orbitals. Then the phenomena are called sp hybridization, sp2 hybridization, and as well as sp3 hybridization. Why carbon atom can form excited state electron configuration? Because the energy difference between 2s orbital to 2p is very small. The excited state electronic configuration of carbon is, the excited state energy of carbon is 502 1.6 kilocalorie per mole. Calorie per mole. Okay, hybrid have identical energies and similar shapes. Okay, now we will discuss one by one hybridization. Thank you. Okay, now here you can observe the first hybridization is sp3 hybridization. Okay, listen carefully. What is sp3 hybridization? sp3 hybridization. One s orbital combines with 3 p orbitals to give 4 sp3 identical hybrid orbital. S orbital shape is spherical, p orbital shape is dumbbell. These two are combined to form this is called tetrahedral arrangement. One s orbital combines with 3 p orbital to give 4 sp3 new identical orbital. This phenomena is called sp3 hybridization. Example for sp3 hybridization: CH4 C2H6. Okay, now I am taking this one. Methane. In methane molecule, the central atom is carbon. It can undergo sp3 hybridization. In this carbon having 4 sp3 hybridized orbitals, hydrogen atomic number 1, electronic configuration 1s1. In this 4 sp3 hybridized orbitals are linearly overlapping with 1s atomic orbital of 4 hydrogen atoms to form 4 sp3 s sigma bond. 4 sp3 s sigma bond. That's why between carbon and hydrogen 4 single covalent bonds are formed. This is called shape of the methane molecule, tetrahedral shape. What is the shape of a methane molecule? Tetrahedral molecule, and bond angle is 109 degrees 28 minutes. 109 degrees 28 minutes. Thank you. Okay, good evening to one and all. Today we will continue one more video, sp2 hybridization. What is sp2 hybridization? The phenomena in which one s orbital combines with 2 p orbital to give 3 sp2 new identical hybrid orbital. This phenomena is called sp2 hybridization. Example for sp2 hybridization is ethene. In ethene, both the carbon atoms undergo sp2 hybridization. Carbon atomic number 6. Electronic configuration of carbon 1s2, 2s2, 2p2. That is ground state electronic configuration. The excited state electronic configuration of carbon is 1s2, 2s1, 2p, x1, 2p, z1. Here one 2s orbital, two 2px, 2py orbitals are combined to give 3 sp2 new identical hybrid orbitals. This phenomena is called sp2 hybridization. Actually, both the carbon atoms, if you take here, the first carbon atom you can observe here, this is first carbon. There are 3 sp2 hybridized orbitals, 1 sp2, 2 sp2, 3 sp2. If you take another carbon atom, 1 sp2 hybrid orbital, 2 sp2 hybrid orbital, 3 sp2 hybrid orbitals. 1 sp2, 2 sp2, 3 sp2. Here also 1 sp2, another carbon. This is also 1 electron, sp2 hybridized orbital of carbon. There are 2 bonds are there to explain the nature of covalent bond, sigma and pi bond. The covalent bond formed between 2 atoms along the internuclear axis are end-to-end overlapping, or axial overlapping, or head-on-head overlapping is called sigma bond. Here sp2 hybridized orbital of one carbon atom is linearly overlapping with sp2 hybridized orbital of another carbon atom to form between carbon and carbon one sigma bond. That sigma bond is nothing but sp2 sigma bond. And if you take here hydrogen atom, atomic number of hydrogen is 1, electronic configuration of hydrogen is 1s1, 1, 2, 3, 4. 4 sp2 hybridized orbitals of both the carbon atoms is linearly overlapping with 1s atomic orbitals of 4 hydrogen atom to form sp2s sigma bond. That means between here sigma bond is formed. Here also between carbon and hydrogen sigma bond is formed. And also here 2pz orbital is there. The 2pz orbital of one carbon atom. Okay, this is called 2pz orbital. The dumbbell shape of the orbital. It is also 2pz orbital. It is unhybridized orbital or pure orbital. It is sidewise overlapping with 2pz orbital of another carbon atom to form pi bond. Then the shape of the molecule is trigonal planar. What is the shape of sp2 hybridized molecule? Trigonal planar shape. And bond angle is 120 degrees. Okay, this is information about sp2 hybridization. Okay, we will continue here. One more hybridization. Another one is sp hybridization. Okay, what is sp hybridization, sir? Okay, listen carefully. One s orbital combines with one p orbital to give 2 sp identical hybrid orbital. This phenomena is called sp hybridization. Example for sp hybridization is ethane molecule. In ethane molecule, the central atom is carbon. Both the carbon atoms undergo sp hybridization. Same here, electronic configuration of carbon is 1s2, 2s1, 2px1, 2py1, 2pz1. This is the excited state electronic configuration of carbon. Here one 2s orbital, one 2px orbital, both are combined to give two sp hybridized orbitals. Okay, this is called one sp hybridized orbital. It is also called one more sp hybridized orbital of first carbon. To take second carbon also, sp hybridized orbital of one carbon, sp hybridized of another carbon. And here 2py, 2pz orbitals are there. That is, this is one 2py orbital, 2pz orbital. It is also dumbbell shaped, no? 2py and 2pz orbitals. Okay, listen carefully here. Okay, sp hybridized orbital of one carbon atom is linearly overlapping with sp hybridized orbital of another carbon atom to form a sigma sp bond. The electronic configuration of hydrogen is 1s1. Okay, sp hybridized orbital of one carbon atom is linearly overlapping with sp hybridized orbital of both the carbon atoms is linearly overlapping with 1s atomic orbital of two hydrogen atoms to form sp s sigma bond. Here also sp s sigma bond. 2py 2pz atomic orbital of one carbon atom is sidewise overlapping with 2py 2pz atomic orbitals of another carbon atom to form pi bond. That is between these two. Here sp py pz pi bond is formed. Pi to py pi to py pi pi bond, pi pz bond. Okay, we can conclude that here in ethyl molecule containing 3 sigma bonds and 2 pi bonds, the shape of the molecule is linear shape and the bond angle is 180 degrees. I hope it is clear. This is information about sp hybridization of organic molecule. And also here how to represent the molecules. Actually, you know, what are the applications of this hybridization? There are various applications are there. It is very easy concept. Okay, applications of hybridization. Okay, in this hybridization concept is useful for the determination of geometry of the molecule and also bond angles and geometry of the molecules. Applications of the hybridization. Applications of hybridization. The first application is to determine the geometry of the molecule and also bond angle of the molecule. Bond angle of the molecule. And the electronegativity, second one, electronegativity of different hybrid orbital. Electronegativity of different hybrid orbital. Different hybrid orbital. Different hybrid orbitals. And hybridized orbitals decrease in the order is different hybrid and unhybridized. Unhybridized orbital The decreasing order is S is greater than Sp is greater than Sp2 hybridized orbital is greater than Sp3 and Pp p orbitals. This is the decreasing order. And also electronegativity of hybrid orbital is directly proportional to the electronegativity of hybrid orbital is directly proportional to the percentage of S character. Percentage of S character. That means here the bond length and bond strength of carbon-carbon bond and carbon-hydrogen and hydrocarbon depends upon the percentage of S character. Bond length and bond strength depends upon the here bond length and bond strength of carbon-carbon and carbon, bond length, bond strength of carbon-carbon bond and carbon-hydrogen bond depends upon some points. That is, the first one is size of orbital is inversely proportional to the size of the orbital. Size of the orbital. Size of the orbital is directly proportional to the, inversely proportional to the percentage of S character. Percentage of S character. And also bond length is also inversely proportional to the here bond length. Bond length is inversely proportional to the percentage of S character. And third one is bond energy, bond strength is directly proportional or inversely proportional to the bond length, percentage of S character. I hope it is clear. Okay, these are the main applications of. Okay, you know what is sigma bond, what is pi bond. Sigma bond is the covalent bond formed between two atoms by end-to-end overlapping or head-on overlapping or linear overlapping or axial overlapping is called sigma bond. Sigma bond is stronger but less reactive due to more effect and stronger overlapping the pi bond. The minimum and maximum number of sigma and pi bond between two bonded atoms is 1. Minimum and maximum number of sigma bonds is equal to 1 only. Stability is directly proportional to the number of sigma bonds, and also sigma bond to determine the shape of the molecule. Sigma bond determine the bond length of the molecule. Stability is directly proportional to the sigma bond. Sigma bond is a free rotation is possible. Reactivity is inversely proportional to the sigma bond. Reactivity less reactive. And pi bond. What is pi bond, sir? The bond formed between two atoms, especially covalent bond formed between two atoms by sidewise overlapping or along the perpendicular to the internuclear axis or lateral overlapping is also called pi bond. Pi bond is a weak bond, it is less stable. After formation of sigma bonds, pi bonds are formed. It is a more reactive due to effective overlapping. The maximum and the minimum number of pi bonds between two hybrid orbitals at two bonded atoms is 0 and 2. minimum pi bonds between two atoms is 0, maximum 2. Okay, pi bond shortens the bond length. Stability is inversely proportional to the pi bond. Reactivity is directly proportional to the pi bond. Okay, these are the characteristics of pi bond. I hope it is clear. And last topic here, how to calculate the hybrid and calculation of hybrid and pure orbitals. Calculate the hybrid and pure orbitals. Okay, number of hybrid orbitals is equal to formula, simply number of carbon atoms into number of donating hybridization of carbon. Number of carbon atoms into number of donating hybridized orbitals. Number donating the hybridization of carbon. Number of donating hybridization of carbon. For example, if you take here, okay, and one more formula here, okay, one more number of pure orbitals. Number of pure orbitals. Formula is 2 into number of hydrogen atom plus number of hydrogen atoms plus 2 into number of pi bonds. Okay, this is the pure orbital or hybridized orbitals formula. Okay, this is called hybrid orbital formula. Okay, hybrid orbital is equal to the number of hybrid orbital is equal to number of carbon atom into number of donating hybridization carbon. Number of pure orbital is equal to number of hydrogen atoms plus 2 into number of pi bonds. Okay, for example, now I am taking here CH2 double bond CH2. How many hybrid orbitals are there here? In this carbon undergoes sp2 hybridization, here also undergoes sp2 hybridization. How to decide, sir? It is sp2 hybridization or sp hybridization. Okay, based on the number of sigma and pi bonds. For example, 4 sigma 0 pi sp3 hybridization, 3 sigma and 1 pi sp2 hybridization, 2 sigma and 2 pi sp hybridization. This is one no. And also one more important point here, single covalent bond is made up of 1 sigma and 0 pi. Double covalent bond is a combination of 1 sigma and 1 pi. Triple covalent bond is a combination of 1 sigma and 2 pi. Okay, these are the main points. Okay, now in this molecule containing number of hybrid orbitals. How many carbons? 2 carbons are there. Okay, the number of carbons into number of donating hybridization. You can observe here, number of hybrid orbitals is equal to sp2 plus sp2. I will write in this side sp2 hybridization. Here also sp2 hybridization. sp2 hybridization means 3 hybrid orbital. Here also 3 hybrid orbitals. Okay, number of hybrid orbitals is equal to 3 plus 3, 6 more. If you take pure orbitals, number of hydrogen atoms 4 plus 2 into number of pi bonds 6 only. Like that, if you take one more example here, CH triple bond CH. Carbon undergo sp hybridization, here also sp. Here 2 hybrid orbitals, here 2 hybrid orbitals. Okay, that means here hybrid orbital is equal to 2 plus 2, 4. Pure orbital is equal to p dot o means pure orbital, h dot o means hybrid orbitals. 2 plus 2 into 2. That means 6 pure orbitals, 4 hybrid orbitals are present. Like that, various examples are there. If you take some more examples here. That is CH3, CH double bond NH. This is one compound. A number of hybrid orbitals, number of pure orbitals here. It can undergo sp3 hybridization, can undergo sp2 hybridization. It is also sp2 hybridization. That means 4 plus 3 plus 3, 10. The number of hydrogen atoms 5 plus 2 into 1 is equal to 7 hybrid orbitals. 7 pure orbitals, 10 hybrid orbitals. So take one more example here. CH3, CH double bond N, CH3, sp3, sp2, sp2, sp3. The number of hybrid orbitals 4 plus 3 plus 3 plus 4 is equal to 14. Pure orbitals is equal to 4, 7 plus 2 into 1, 9. 14 hybrid orbitals, 9 pure orbitals. Like that, we can calculate number of hybrid and pure orbitals of various organic molecules. I hope it is clear. Thank you. Continue one more video here. Representation of the organic molecule. There are millions of organic compounds are there. Representation of organic molecule. There are millions of compounds are there. How to represent? Actually, the formula of a compound is represented by empirical formula and molecular formula, and structural formula is classified into 4 types. How to represent the organic compounds? The first one is structural formula. For example, if you take methane, this is called structural formula. If you take ethane, this is called complete structure form. Propane, CH3, CH2, CH3. Second one is condensed formula. Condensed formula is nothing but in the CH4, C2H6, C3H8, etc. Third one is Lewis dot structure. Lewis dot structure means, for example, if you take here methane, this is called Lewis dot structure. Methane, ethane, Lewis dot structure. And finally, one more way is bond line structure. Bond line structure. Bond line structure is nothing but, if you take here, only bonds are there but not in hydrocarbons. If you take, this is called ethane molecule. Okay, ends of the bond is nothing but carbon. Okay, one bond means between two carbons, one single covalent bond is there. Okay, this is called complete structure form. If you take here, this is called one bond between carbon and carbon, single bond between carbon and carbon. Okay, one bond is nothing but remaining three are hydrogens. Here two bond means two hydrogen. Here Nana, propane, butane, butene, two butene. Like that, these are all bond line structures. Okay, not only this one, if you take here, it is also bond line structure. Like that also. These are all bond line structures. How to represent this bond line structure? Here single bond is nothing but here carbon, here CH2, here CH3, CH2, CH3. Here one bond is there CH3, three bonds CH, CH, CH3. Here double bond is there, that means CH2, CH, CH, CH2. Here CH3, CH, 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 C, CH3, CH3. I hope it is clear. There are four ways to represent the organic molecule. Thank you. Now we will continue here. Classification of hydrocarbon. Actually, the hydrocarbons are broadly classified into, the organic compounds are broadly classified into organic compounds broadly classified into two categories. That is called open chain hydrocarbons, open chain hydrocarbon, and second one is closed chain hydrocarbon. Open chain hydrocarbon, closed chain hydrocarbon. Open chain hydrocarbon is nothing but when the carbon atoms are connected with each other or linked with each other in an open manner, either straight chain or branch chain or closed chain. When the carbon atoms are connected with or linked with other carbons to form a straight chain or branch chain or ring chain is called open chain hydrocarbon. This open chain hydrocarbon is also called acyclic hydrocarbon. It is also called aliphatic hydrocarbon. Once again repeat, open chain hydrocarbon is nothing but the hydrocarbon in which when the carbon atoms are linked with each other to form a bigger molecules, either straight chains or branched chains, but not ring chains. When the carbon atoms are linked with each other, if you take carbon, it is linked with each other to form a straight chain, or if you take a branched chain, like that compounds are called what, Nana? Open chain hydrocarbons. These open chain hydrocarbons are broadly classified into two categories, that is saturated hydrocarbon and another one is unsaturated hydrocarbon. Saturated hydrocarbon is nothing but the carbon compounds in which at least between carbon and carbon one single covalent bond is present, then the compounds are called saturated hydrocarbon. Okay, the hydrocarbon in which at least one single covalent bond between two carbon atoms in a molecule is called saturated hydrocarbon. It is also called alkane. Okay, alka is nothing but number of carbon atoms. Okay, the general formula of alkane is CnH2n plus 2. The simplest alkane is meth. If the molecule containing one carbon, then the root word is meth. Methane, 2 carbons C2H6 ethane, 3 carbons propane, and so 4 carbons butane, 5 carbons pentane, 6 carbons hexane, 7 carbon 8 octane, 8 carbons octane, 7 carbon heptane, 9 carbon nonane, 10 deca. Like that, these are all number of hydrocarbons, saturated hydrocarbons. Okay, what is unsaturated hydrocarbons are the hydrocarbon in which at least the double bond or triple bond between two carbon atoms in a molecule. The hydrocarbon in which at least between carbon and carbon either double bond or between carbon and carbon at least one triple covalent bond between two carbon atoms in a molecule is called unsaturated hydrocarbon. This unsaturated hydrocarbons can classified into two types, that is alkene and another one is alkyne. What is the alkene, sir? The hydrocarbon in which at least one double covalent bond between two carbon atoms in a molecule. The hydrocarbon in which at least one double covalent bond between two carbon atoms in a molecule is called alkene. The general formula of alkene is CnH2n. So what is alkyne, sir? The hydrocarbon in which at least one triple covalent bond between two carbon atoms in a molecule is called alkyne. The general formula of alkyne is CnH2n minus 2. CnH2n minus 2. Okay, alkenes and alkynes starts with the second carbon. The simplest alkene is ethane C2H4. The simplest alkyne is C2H2. I hope it is clear. Okay, here if N is equal to 2 ethene, 3 carbons propene, 4 carbons butane, 5 carbons pentane, 6 carbons hexane, 7 carbons heptane. If you take triple bond between CnH2n minus 2 starts with second carbon, ethane, propane, butane, pentane, hexane, heptane, nonane, decane. And one more important point here, a removal of hydrogen from alkane is called alkyl. Removal of hydrogen from alkene is called vinyl or alkenyl. Removal of hydrogen from alkyne is called alkynyl. Removal of hydrogen from alkane is called alkyl. Removal of hydrogen from alkene is called alkenyl or it is also called vinyl. Removal of hydrogen from alkyne is called alkynyl. This is information about open chain hydrocarbon. I hope it is clear. Thank you. We will continue here. Closed chain hydrocarbon, it is also called cyclic compounds. Closed chain hydrocarbons. It is also called cyclic compounds. They are again classified into two categories, that is called homocyclic and heterocyclic compounds. Homocyclic compounds, it is also called carbocyclic. They are again classified into two categories, that is called alicyclic homocyclic compounds, heterocyclic compounds. Here also heterocyclic compounds again classified into two categories, alicyclic heterocyclic compounds, aromatic heterocyclic compounds. Alicyclic homocyclic compounds. Alicyclic homocyclic compounds, aromatic homocyclic compound. Here also aromatic heterocyclic compounds. What is homocyclic compounds? What is closed chain compounds? The compounds in which the hydrocarbons, in which when the carbon atoms are connected with each other to form a closed ring manner or closed form, then the compounds are called closed chain. When the carbon atoms are connected with each other in a ring manner or closed manner, like that cyclopropane, cyclobutane, cyclopentane, closed chain. When the carbon atoms are connected with each other in a closed manner is called closed chain or cyclic compounds. They are classified into two categories, homocyclic compounds, heterocyclic compound. What is a homocyclic compound? Homo is nothing but same. If the ring containing only one atom, it is also called simply carbon. That's why the ring containing only carbon atoms, then the compounds are called homocyclic compounds. At least one heteroatom present in the heteroatom, like oxygen, nitrogen, sulfur, fluorine, etc. If the ring containing at least one heteroatom present in the ring, then the compounds are called, other than carbon, at least one heteroatom. If the cyclic compound containing at least one heteroatom is present, then the compounds are called heterocyclic compound. This homocyclic compound is also called carbocyclic compounds. Carbocyclic compounds. They are again classified into two categories, alicyclic aromatic compounds. What is alicyclic compounds? The homocyclic compounds which are resembles with aliphatic compounds. Which are resembles with aliphatic compound means, okay, the homocyclic compound which can resembles with alkene properties, like especially general forms. Okay, the general formula of alkene and cycloalkanes are similar. That's why simply the cyclic compound, homocyclic compounds which are resembles with aliphatic compounds. This is called alicyclic compound. Example for alicyclic compounds, especially cyclopropane, cyclobutane, cyclopentane, cyclohexane, benzene. These are all. Not benzene, only this type of cyclohexane, cycloheptane, etc. What is aromatic compounds, sir? Aromatic homocyclic compound means the hydrocarbons, the cyclic compounds containing at least one 6-member ring with alternate single and double bond. Okay, the cyclic compound containing a 6-member ring with alternate single and double bond, or 2 or more fused rings, or 2 or more isolated rings, is called aromatic compounds. They are classified into two categories, benzenoid compounds, non-benzenoid compounds. Benzenoid is nothing but if the aromatic compound containing at least one benzene ring. If the aromatic compound without benzene ring is called non-benzenoid. Okay, aromatic compounds are classified into two types, benzenoid compounds and non-benzenoid. If the aromatic compound containing at least one benzene ring is called benzenoid compounds. If the aromatic compound without benzene ring is called non-benzenoid. I hope it is clear. Okay, alicyclic heterocyclic compounds. Okay, the heterocyclic compounds. What is a heterocyclic compound? At least one heteroatom. For example, if you take here oxirane, oxetane, CH2, CH2, CH2. Okay, they are again classified into two categories: alicyclic, the heterocyclic compounds which are resembles with aliphatic compounds, especially this one, oxirane, oxetane, tetrahydrofuran, etc. If the compound containing pyrrolidine, tetrahydrofuran, oxetane, oxirane, these are all examples for alicyclic heterocyclic compounds. Okay, what are the examples for alicyclic heterocyclic compounds? Okay, simply this is called oxirane, CH2, CH2O. This is called oxetane. Next, you take pyrrolidine. This is called tetrahydrofuran. Pyrrolidine means a 6-member ring with nitrogen, NH. Pyrrolidine. These are all alicyclic heterocyclic compounds. What is the aromatic heterocyclic compounds? Okay, the heterocyclic compounds which are resembles with the aromatic nature, most of their properties are called aromatic compound. Example: pyrrole, thiophene, and also furan, pyridine, etc. Example for aromatic heterocyclic compound, this is called furan, thiophene, pyridine, or if you take thiophene, thiophene means 6-member ring with sulfur. Sorry, only 2 bonds are there here only. Furan, thiophene, pyrrole. Pyrrole means NH. This is called thiophene. This is called furan. This is called pyridine. This is called pyrrole. Okay, this is information about classification of organic compounds. Okay, now we will continue here. Conditions for aromatic compounds. What are the conditions are here? Aromaticity. Conditions for aromatic. Condition for aromatic compounds and non-aromatic. Okay, the compound should be cyclic, the compound should be planar, the compound should be conjugation, the compound must be, there are various conditions are there. The first one is the compound must be cyclic, the compound must be planar, conjugation, or the compound should be delocalization of 4n plus 2 throughout the cyclic system. It is called Huckel's rule. It is applicable for only monocyclic compounds. Aromatic compounds are delocalized bonding. That means all the atoms in the ring system is sp2 hybridized. Conjugation takes place. Conjugation is nothing but alternate bonds. There are various ways. The first one, double bond, single bond, double bond. Second one, double bond, single bond, positive charge. Next one, double bond, single bond, negative charge. This is first way. Second one. Third one is double bond, single bond, negative charge. And fourth one is double bond, single bond, lone pair of electrons. These are all conjugation takes place, and it can obey Huckel 4n plus 2 pi electron, where n is equal to integers 0, 1, 2, 3 and so on. If n is equal to 0, number of electrons is equal to 2 electrons. If n is equal to 1, 6 electrons. N is equal to 2, 10 electrons. N is equal to 3, 14 electrons. This electron is nothing but conjugation. Simply we can conclude that what are the conditions for the aromatic? The compound should be planar and the compound must be cyclic. The compound should have delocalization of 4n plus 2 throughout this cyclic system. It can obey Huckel 4n plus 2 pi rule. Conjugation must be takes place. And also number of electrons. How to calculate the number of electrons here? The number of electron is nothing but double bond is nothing but 2 electrons. Lone pair of electron is nothing but 2 electrons. Negative charge is nothing but 2 electrons. These are the key points. This one and this one. If you take some example here, this is aromatic or anti-aromatic. What are the conditions for non-aromatic? This is a condition for aromatic. What are the conditions for non-aromatic? If you take non-aromatic also here, non-aromatic, the compound should be cyclic, the compound should be planar, the compound should be non-planar, anti-aromatic, not non here, anti-aromatic compound. What are the conditions for anti-aromatic? The compound should be cyclic, the compound should be planar, the delocalization of sp2 hybridization, conjugation, and here Huckel 4 and 5 rule. The only difference here, Huckel 4 and 5 rule only. You can obey Huckel 4 and 5 rule only. It can obey Huckel 4 and 5 rule. Okay, here n is equal to 1, 2, 3, 4 and so on. Okay, if n is equal to 1 is nothing but 4 electrons. 4 electron is nothing but anti-aromatic. 8 electrons anti-aromatic. 12 electrons anti-aromatic. 16 electron anti-aromatic. Okay, I hope it is clear. I will give some examples for you how to decide the conjugation, or it is aromatic or anti-aromatic. If the compound is aromatic or anti-aromatic, how to decide, sir? Okay, I will give some examples. You will try here. What are the examples here? For example, if you take this compound, it is aromatic or non-aromatic. Check once here. First conjugation of double bond, single bond, double bond. That's why it's conjugation cyclic compound. How many electrons? It is a anti-aromatic. 4 electrons are there. Double bond, single bond, positive charge. 4 electrons are there. Anti-aromatic. Double bond, single bond, negative charge. How many electrons here? Here, double bond, 2 electron, double bond, 2 electrons. 6, 4 plus aromatic compound. Okay, 6 electron is nothing but aromatic only. 6 electron is nothing but aromatic. So like that, if you take this compound, 1 to 6 electron is nothing but aromatic compound. 1 to 4 electrons only anti-aromatic. 6 electrons aromatic compound. It is not aromatic compound. It is also aromatic compound. How to decide? Based on the number of electrons. Okay, 4 and plus 2 5 rule. 4 is 4 and 5. This is a non. Okay, what is a non aromatic compound? Compound must be cyclic and non-planar. Delocalization either 4 and plus 2 4 and 5 rule. The energy of aromatic compound is less energy corresponding aliphatic conjugated system. Okay, simply non-benzenoid compounds is not non-aromatic is nothing but should not obey either conjugation. I hope it is clear. And another one is homologous series. What is the homologous series, sir? Homo means same. Logos means sequence. Same. Logos means sequence. Okay, the series of compounds in which two successive compounds differ by one CH2 unit. If you take alkane, the general formula of alkane is CnH2n plus 2. If you take alkene, the general formula of alkene is CnH2n. If you take alkyne, the general formula of alkyne is CnH2n minus 2. The simplest alkene methane, C2H6 ethane, C3H8 propane, LC2H4, C3H6, C4H8, here C2H2, C3H4, C4H6, etc. Okay, the series of compounds in which two successive compounds differ by one CH2 unit. Okay, the series of compounds in which two successive compounds differ by one CH2 unit is called homologous series, or it is differ by simply 14 AMU. Okay, the two compounds are differ by one CH2 unit is nothing but 14 AMU or 14 mass is called homologous series. Okay, what are the characteristics of homologous series? They have one general formula. For example, if you take alkane, general formula is CnH2n plus 2. Alcohol CnH2n plus 1 OH. If the molecular mass of two successive members of homologous series is different by 14 AMU. Similar methods may be employed to prepare all the compounds belonging to homologous series. The physical properties of the compounds of homologous series change gradually as the molecular mass changes. For example, melting point, boiling point, density, viscosity is increases with the molecular mass. The chemical properties of compound belonging to same homologous series is similar. Is simply two successive compounds are differ by one CH2 unit. Is called homologous series. I hope it is clear. Thank you.